Hello everybody, my name is Ajay Sitpara. I am a research scholar at Mechanical Engineering Department, IIT Kanpur. Today I am going to give you a brief description of electro discharge machining process, and shortly it is called EDM process. This electric discharge machining has four basic components. First component is dielectric tank, in which the dielectric material is kept inside and which is circulated by this pump, so that the dielectric can get filled and material removal can take place after that machining. And second is the machining chamber, in which the workpiece and tool are kept on a positive and negative terminal that I will show you later on. This is the machining chamber, in which the Z axis of CNC machine head is attached, and in this part here the tool is attached on the negative terminal and workpiece is attached to the positive terminal. I will show you later on this regard also. In this is the control panel on which the all machining parameters can be set, so that the different machining condition can be performed and material removal takes place according to our desired accuracy. This is the machining chamber. In that you can see this is the workpiece material and this is the tool attached to the Z axis of this machine, and this Z axis of the machine is connected with the negative terminal of the power supply, and this workpiece is connected to the positive terminal of the power supply. And once this dielectric chamber is filled, after that you can start machining. Now I am starting this control panel. Now press any key to continue. Now these are the various process parameters which you can control by this machine, and this is the X, Y and Z position. At present X and Y position are 0 and Z axis of this tool axis is at 36.6 in positive direction. Now I am going to explain you how to set different parameters. In this is IP, this is the input current. If you increase this current, then the machining takes place at higher rate and the surface roughness will increase. So according to the process requirement you can set the higher or level current. And the second one is the T on time. T on time is how much time that machining can take place in a particular cycle, so that sparking can take place. And third one is the T, which is the T off time, because in EDM process there are on time and off time. Off time is the part of the total cycle in which the machining cannot be take place and the removed material can be swept away by the dielectric fluid. And this fourth one is the gap voltage. This gap voltage depends on the how much gap you can control in this particular process. And this is the sensitivity. Sensitivity is nothing but the movement of the servo motor. If the sensitivity is very high, then the servo motor of the Z axis will move very slowly. At present it is 7 and total range is 0 to 14, so presently it is on the 50%. And this one is the arc sensitivity, in which the machining arc take place, then it will give some alarm so that you can stop machining process and workpiece will not be damaged for the further processing. And this is the tool wear. So tool wear can govern depends on the which type of material and tool workpiece combination you have chosen. Depending on that combination you can select the tool wear. And this one is the T. T is nothing but a time on which the machining takes place. So it is the total amount of time when the workpiece and tool are in near to the machining area. And this is IB. It is not particularly used for this machining process right now. And now this menu gives flex. The flex is nothing but some type of alarm with some machining takes place, and at that time there are some unwanted noises are there, then this alarm will give. This is the auto flush, then speed up, buzzer, servo, dwell time. Dwell time is that when machining takes place, then you can give some dwell time so that machining can take place at a higher rate. At present there is most of these are off and these first three are on, so that you can get some alarm if machining is not taking place at a particular choice. And now this is the edit command, where you can edit by this pressing F10. So once you have pressed F10, then here you can see there are different parameters. First is edit, This is flag. Now flag area, this part is active right now. Then press DRO. DRO means you can set the position of X, Y and Z. Once you can touch this workpiece with the tool, at that time you can press 0 so that X, Y and Z all are 0 at a particular level. Now there is a program. Now you can write different program in this file, and edit means already written program you can edit as per your choice. Now this F9 is the pump. Pump is that you have to fill this dielectric chamber before start machining, and this Z down is movement of Z axis, Z up is movement of Z axis again. Alarm reset, if some alarm is given by this control panel, then you can press this button to switch off that alarm. And then end step, this means if you are giving a step machining, then you can set by this F5 button, and standard step is F4. Auto position means once you get some particular distance between the workpiece and tool, after that you press this auto position so that the workpiece and tool gets set automatically. There is no need to give a extra motion. Hold means once you give a machining operation, at that time suppose you want to stop machine in a particular movement, then you press hold, then machining will cease off. And spark means machining starting time. When you press F1 button, then machining starts. The first operation before start machining is to set X, Y and Z at particular positions. That is called 0, 0, 0 position or work position. So presently X and Y at 0 position, but there is a gap between tool and workpiece. So I will give command of auto position so that this workpiece and tool get touch here, and so that I can press Z as a 0, 0, 0. Now it is auto positioning the tool and workpiece. Now tool and workpiece are in touching position. So now this is the 0, 0, 0 position. After positioning X, Y and Z axis at a 0, 0, 0 position, now I will retrieve this Z axis. Now the second step of this process is to fill up this machining chamber with dielectric. The tool and the workpiece should be submerged in the dielectric fluid. After that, the machining we can start. Now tool is moving towards the workpiece position. Now machining has been started. Now you can clearly see the sparking between tool and workpiece. After completion of machining process, you can retrieve this Z axis to a particular higher level. And after that, you have to remove all this dielectric fluid from the machining chamber. This alarm shows the dielectric level is very low, so that we can fill up the dielectric again if we want to start machining again, but there is no need at present, so I am switching off this alarm. Now you can see there is some material removal from the workpiece surface here, because this is a thermal process. In this process, material removal will take place from the workpiece as well as from the tool also. That depends on the which type of polarity you have given in this particular process. Whichever the part is connected with the negative polarity, it will remove at a lower rate, and which one is connected with the positive polarity, it will get removed at a more faster rate compared to the negative polarity. Now you have just seen the working principle of the EDM process. Now this EDM process is basically used for die and other mold manufacturer, because this is the process in which you can control the finishing accuracy as well as machining accuracy at a particular level, and it can give a good surface finish as well as material removal, and there is no any limit of the workpiece hardness. But the basic problem with this process is this machining process can be used for conductive material only, and any hard material but which should be conductive material, then only this EDM process can work. Thank you for your presence.